In this last lesson on discriminant, we're going to look at a more complicated example. The example says, for what range of values of k does the equation k bracket x plus 1 bracket x plus 4 equal x have real roots? This uses the same techniques as we've used before. The algebra just gets a wee bit trickier, that's all. So first thing we have to do is sort this out so we can get our values for the discriminant, the a, b and c values. So multiply the bracket out first of all. So you're going to get x squared plus 5x plus 4 equals x. The next thing to do is we want really to get this x over the other side, but before that we have to multiply the bracket through by k. So kx squared plus 5kx plus 4k equals x. It's important to put the 5k before the x because at that moment that's the coefficient of the x. Next we'll take the x over to this side, so if I subtract x but put it next to this one here, we want these to be next to each other because they're both x terms. So when we do that, you end up with this. Now, to get a value, you just look at that. We've got k here. That's going to be a. To get b, the coefficient of x, we need to do one more thing. So we look at this bit and we think, we've got 5kx, take away x. We can take a common factor of x out to leave us with the coefficient. So we'll do that in the next line. So if we take x out of this, you end up with 5k take away 1. Then you've got your 4k equals 0. So that's your a. Oops. That's a, that's b, and that's c. We can then go into our b squared minus 4ac. So we're trying to see where they have real roots. So that means that b squared minus 4ac is greater than or equal to 0. So set our equation up. 5k minus 1 squared. Take away 4 times k times 4k is greater than 0. We'll sort this bit out. Minus 16k squared. Multiply the brackets out, so that's going to give us 25k squared minus 10k plus 1. Take away 16k squared is greater than 0. And then you can take away the negative 16k squared from the 25k squared. And that will give you this. Put it into double brackets. So you need a 9k at the start, and a k at the start of the next bracket, and a 1 and a 1. You could have a 3 and a 3, but 3 and a 3 is not going to give you your 10. So it's going to end up like this. 9k times k gives you the 9k. Negative 1 times negative 1 gives you your 1 at the end. And you've got a negative k from this part, and a negative 9k from this part. Next thing to do to find out when this is greater than or equal to 0, sketch the graph. So we've got roots at a 9th and 1, and we're looking for when this is greater than 0. So that's all these values, this side, and all these values, this side. So all this side means that k needs to be less than or equal to a 9th, and this side k needs to be greater than or equal to 1. So a finishing statement.